Good evening, children. So, understanding quadrilaterals is the third chapter, if I'm not wrong, in your NCERT maths textbook. The first chapter is rational numbers, and then I don't know the order, linear equations, and then correct? Yeah. So this is the third chapter. Okay. Your NCERT math textbook, it's a third chapter. All right. So let's understand some keywords, key terms which are used in this chapter. See the first one, curve. Right? Okay. So when you see, this is a writing instrument. All right. This is a writing instrument. Now, when I trace a figure or draw a figure, okay, with the help of any writing instrument, without lifting my hand, I don't lift my hand. Without lifting my hand, I do whatever like this. I don't lift my hand. This is a curve. This is a curve. A curve is a figure which is traced or drawn on a plane surface, which is drawn or traced on a plane surface using a writing instrument. So here you see a sharp pencil, but any writing instrument, all right? So a figure traced or drawn on a plane surface using a writing instrument, a sharp pencil, a pen, whatever, without lifting. You should not lift. See, if I draw something like this is not a curve. Why? Because to draw this, I have to go like this. Then to get the other line, I'll have to lift. I'll have to lift and then draw like this. So this one is not a curve. This one is not a curve. This one is also not a curve. See here, I go like this and then I have to lift my hand and I go like this. This figure is not a curve. The figure in total is not a curve. See, this one is a curve. This one is a curve. Because I'm able to draw this without lifting. I'm able to draw this with a writing instrument without lifting. So a curve is a figure which is traced on a plane surface, okay, without lifting. How do you trace? Using a writing instrument, a pen or a pencil. Okay, so you trace using a pen or a pencil on a plane surface without lifting. Without lifting is called a curve. That without lifting is important, is a curve. All right. Okay. Now, what's an open curve? If the starting point and the ending point is the same, or in other words, if the curve ends at the starting point, if the curve ends at the starting point, open curve, okay. If the curve does not end at the starting point, if the curve does not end at the starting point, so say you start here, and you end here. You started here. This is the starting point, and you end here. You start like this, you go like this, and you end here. This is the starting point. This is the ending point. The 2 points are not the same. The starting point is different from the ending point, right? That is, the curve does not end at the starting point. The curve does not end at the starting point. So it's an open curve. In simple words, if the starting point and the ending point are not the same, it's an open curve. If the starting point and the ending point is the same, then it's a closed curve. So if I go like this and I finish it here, it's a closed curve. Because you start here, I started here, I go like this, like this, like this, and I come back to the starting point. I finish at the starting point. Where do I stop? At the starting point. If the starting point and the ending point is the same, it's a closed curve. If the starting point and the ending point, they are not the same, they are different, it is an open curve. So look at this one. First, is it a curve? Yes, because you're able to draw this without lifting the pen or pencil. You're able to trace this figure. You're able to draw this figure without lifting the writing instrument. So it is a curve. First, we should see to say if it's an open curve or a closed curve. Is it first a curve? Is it a curve in the first place? For that, what should you check? If you were able to draw or trace it without lifting the writing instrument. So yes, you are able to do this without lifting the writing instrument. So it is a curve. Next, this is the starting point. This is the ending point. They are different. So it's an open, it is a curve. And now it's an open curve because the starting point and the ending point, they're different. It's not the same. So it's an open curve. But if you go like this is the starting point. Without lifting the writing instrument, you're able to finish it like this. The starting point is equal to the ending point. It's a closed curve. It's a closed curve. See the number 8 also. You come back to the starting point. You're able to do this without lifting the writing instrument. You go like this without lifting the writing instrument, you come back to the starting point. So it's a closed curve. Correct? What is a curve? A figure which is drawn or traced on a plane surface, meaning a flat surface, using a writing instrument without lifting it, is a curve. It can be any shape. It can be crooked, anything it can be. You should not lift the writing instrument. Okay. Okay, that's a curve. Open curve, starting point and the ending point, they are not the same. Closed curve, starting point is equal to the ending point. Okay. Now a simple closed curve. A simple closed, see the terms there, simple closed curve. So it should be a curve. It should be a closed curve. Then only you can say something is a simple closed curve. If you have to call a curve a simple closed curve, first it should be a curve. It should be a closed curve. And then you can check if it is a simple closed curve. So first it should be a curve. Okay. All right. So simple means the curve should not intersect itself. The word simple means the curve should not intersect itself. It should not cross over itself. Now see, when you write this, when you draw or trace this number 8, see the curve intersects itself here. No, it goes over itself. It crosses itself. Now, this one is a curve. Why is this a curve? This figure is a curve. This one meaning this figure. This figure is a curve because you are able to draw this without lifting the writing instrument. So it's a curve. It's a closed curve because the starting point and the ending point is the same. So it's a closed curve. But it is not a simple closed curve because in the figure, you can see it crosses over itself. The figure crosses over itself. See here, it goes over itself. You can find this intersection point here. So it's not a simple closed curve. If the curve crosses over itself or it intersects itself, it is not simple. Simple means if it is simple, it should not intersect. If it intersects, it is not simple. Simple means what? It should not cross over itself. Then it is simple. It should not cross over itself. So this number 8 is a curve, is a closed curve, but it is not a simple closed curve because it crosses over itself. You can find this intersection point here, right? Okay. So what is a simple closed curve? A closed curve. See, a simple closed curve is a closed curve which does not intersect itself. It should not intersect itself. So if you draw this figure like this one is a curve because you're able to see. You should not say, oh, accidentally while drawing it, I lifted the pen. So is it a curve? You lifted is the different thing. Can you draw without lifting? See, you lifted. Somebody rang the doorbell, so you had to answer the doorbell. So you did this and the doorbell rings, so you leave and you go open the door and you then come and complete it. That doesn't mean you do it by lifting. Not like that. You can draw this without lifting the writing instrument. So it is a curve. It's closed. It's closed because the starting point is equal to the ending point. So it's closed. But it is not simple because it crosses over itself. So it's not simple. If you're not able to sit there, take the next row. Then don't talk. All right, simple. Then polygon. What's a polygon? A polygon is a simple closed curve made up of line segments. A simple closed curve made up of line segments. Now, this one is not made up of line segments. Can you see this? Is this figure made up of line segments? No, but it's a curve. Is this one made up of line segments? No, but it's a curve. It's a curve because you're able to draw this without lifting the writing instrument. Now, is this a curve? Yeah, because you are able to draw this without lifting the writing instrument. But is it completely made up of line segments? No, it's not completely made up of line segments. It's not completely made up of line segments, right? Okay. Now, this one is a curve because you're able to draw this without lifting the writing instrument. It is a closed curve because the starting point is equal to the ending point. It's a closed curve. And it is a simple closed curve because it doesn't intersect itself. It is a simple closed curve. It doesn't cross over itself anywhere. But it's not a polygon because, yeah, because a polygon is a simple closed curve made up of only line segments. Okay, so this one is not a simple closed curve. Sorry, this one is not a polygon. Sorry, this one is not a polygon. It's a simple closed curve, but not a polygon. You can quickly do it from the beginning. Is it a curve? Yes, because you can draw it without lifting. Then is it simple? Yes, because it doesn't intersect itself. Is it closed? Yes, because the starting point is equal to the ending point. Check all the three terms. Is it a curve? Is it a closed curve? Is it a simple closed curve? Yes, for all the three, it is yes. It is a curve, it's a closed curve, it's a simple closed curve. Now, is it made up of line segments? No, it's not completely made up of line segments. So it's not a polygon. Because what's a polygon? A polygon is a simple closed curve made up of only line segments. Made up of only line segments. All right. And every straight line segment in that polygon is called its side. So a triangle is a polygon. But how did I draw it? I did it like this. I lifted. No. You can, that's what I'm trying to say. You can draw a triangle like this. I draw it like this. That doesn't mean it's not a curve. That's what I'm trying to say. See, I drew the triangle now like this. I lifted the writing instrument. Okay. We can draw it without lifting. So it's a curve. So now see here. This one is a curve because we are able to draw it without lifting the writing instrument. It's a closed curve because the starting point is equal to the ending point. And it's a simple closed curve because it doesn't cross over itself. And it's made up of only line segments. So it is a polygon. So all these conditions must be satisfied for a figure to be called a polygon. So you know many polygons. A triangle is a polygon. A quadrilateral is a polygon. A pentagon is a polygon. Hexagon, heptagon, octagon, nonagon, decagon. All these are simple closed curves made up of line segments. So in curves, you have open curve, closed curve, simple curve. What's an open curve? It's not the same. What's a closed curve? What's a closed curve? Yeah. What is a simple curve? Yeah, a simple curve meaning it should not intersect itself. It should not intersect itself. Then it's a simple curve. Okay. Okay. Once again, open curve will be different. Closed curve, simple curve, it doesn't intersect itself. Okay. Then simple closed curve. If you have to check for a simple closed curve, it should be a simple curve. It should be a closed curve. It should be a simple curve. It should be a closed curve. So what's a simple curve? Cross over itself or intersect itself. What's a closed curve? The ending point and the starting point is the same. Very good. You can turn off your camera, Srijit. You just joined, is it? Turn off your camera. You just joined?
Yes, ma'am. Yes, ma'am.
Okay. Yeah. Then polygon. How do you check if a figure is a polygon? It should be a simple closed curve made up of line segments. It should be a simple closed curve made up of line segments. All right. Srijit, you missed about, I think, about 20 minutes of the class.
Yes, ma'am. It was network issue, ma'am.
Okay. So stay in the meeting, just see how much you can understand, because since you missed the introduction part, I'm not sure if you can follow ahead. I'll share the recording. You can go through the recording. Okay.
Okay, ma'am.
Yeah. You try to follow the rest of the meeting.
Okay, ma'am.
Yeah. So that's about curves. Curve, simple, sorry, curve, open curve, closed curve, simple curve, and then simple closed curves made up of line segment, which is a polygon. The shaded region represents the interior of the curve. The blue region, the blue shaded region represents the interior of the curve. And in the second figure, the white portion is the interior. The blue portion is the exterior. In the second figure, the white portion is the interior of the curve. The blue portion is the exterior of the curve. In the first figure, the blue portion is the, in the second figure, the blue portion is the, yeah, the white one is the interior, the second one. Okay. Now curves that are not polygons and curves that are polygons. Now see the figures here. Now all these are made up of line segments, correct? All these are made up of line segments. Now what is a polygon? It should be a simple closed curve made up of line segments only. Simple closed curve made up of line segments. Okay, so see the first one, the first figure. See, we can draw the first one like this. Correct? You are able to draw it without lifting your hand. So it's a curve. And it's a closed curve because the starting point is equal to the ending point. And it is a simple curve because it doesn't cross itself. So this one is a simple closed curve. And it's made up of only line segments. So it's a polygon. So it's a polygon. So like that, you can check for all the three. All these three are simple closed curves made up of line segments only. So they are polygons. But in the second box, what you see here, these three figures, they are all, you can see line segments there. You can see line segments. But in the first one, in this one, it's not closed. It's not closed because the starting point and the ending point, they're not the same. It's not closed. So this one is not a polygon. It's made up of line segments. It's made up of line segments, but then you can see it's not closed. So this one is not a polygon. And here it crosses over itself. It's made up of line segment, but it crosses over itself. That means it's not simple. It's not simple. What's a polygon? It's a simple closed curve. It's a simple closed curve. But this one is not simple because it crosses over itself. So this one is not a polygon. And here, starting point and the ending point, they're not the same. It's not a closed curve. It's not a closed curve. Right? In these three figures, the definition is satisfied. The definition of a polygon is satisfied. What is the definition of a polygon? A polygon is a yeah, very good. A polygon is a simple closed curve made up of line segments. So all these three figures, they are closed curves, and they are simple closed curves because you can see that they don't cross over themselves. So they're simple closed curves, and they're made up of only line segments. So these are polygons. Why are these not polygons? These three are made up of line segments, right? Then why are they not polygons? Because in the first one, the starting point and the ending point, it's not the same. So it's not a closed curve. So this one is not a polygon. In the second one, it crosses over itself. So it's not simple. It's not simple. So it's not a polygon. The third one, the starting point and the ending point is not the same. Again, it's not closed. So it's not a polygon. Yeah. Now identify as open curve, closed curve, simple closed curve, polygon. Now all of you have completed this, no? You have these figures in your notebook, right? Yeah, do it in your book. Use a pencil. Use a pencil and name them. Against every figure, just mention open, closed, or simple closed curve or polygon appropriately. The order might change. Yeah, it's okay. You look into your notebook and you use your notebook, what you have in your book, no? Use that and mark it. We'll discuss. Srijit, you got my instruction?
Ma'am, yes, ma'am.
Okay. Use a pencil to write the appropriate term against the figure so that in case, we are wrong, you can erase it and correct the answer.
Okay, ma'am.
Not a curve. Okay, that is not given, is it? Yeah, okay. Don't give any name. Just leave it because I'm not a curve. You can write not a curve. Yeah. Finished, Tanvin? Yeah. 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 Harini, the first one. It's an open. Is it a curve? Yeah. Why is it a curve? Yeah, very good. You can draw it without lifting your hand. Okay, so it's a curve, but it's an open curve because this is the starting point, but this is the end point, ending point. Like you go like this, like this. Okay, so this is an open curve. Very good. The first one is an open curve. Second one, Anirudh, open curve. You cannot say it's a polygon because it's made up of line segments. What's a polygon? What are the things that a polygon should satisfy? It should be a simple closed curve made up of line segments. Simply because you see line segments, it cannot become a polygon. A polygon is a simple closed curve. It should be a curve. It should be a closed curve. It should be a simple closed curve and made up of line segments. Only then it's a polygon. So here you have line segments, but it's not a polygon. It is an open curve, correct? Open curve because first it's a curve because you are able to draw this without lifting your hand. So it's a curve. But the starting point and the ending point, they're different. So it's an open curve. Third one, closed curve. Is it a curve? Yeah, because you can draw it without lifting your hand. So it is a curve. And it's a closed curve because the starting point and the ending point is the same. So it's a closed curve. Very good. Yeah, Dhanvan, next one. It's a simple closed curve. One second. Why is the third one not a simple closed curve? Correct. The third one is a closed curve, but you cannot call it a simple. The third one, you cannot call it a simple closed curve because it intersects itself.
It's cross itself, ma'am.
Yeah, it's crossing over itself. Very good. Yes. So it's only a closed curve, but the fourth one is a simple closed curve. It is a simple closed curve. You can analyze word by word. It is a curve because you can draw without lifting. Then it's closed because the starting point is equal to the ending point. And it's simple because it doesn't cross over itself. Every word has a meaning. Okay, fine. Now, can you, okay, so this one is a simple closed curve, right? Then why don't you call it a polygon? Because it's not made up of line segments. This one is not a line segment. This one is not a line segment, and this one also is not a line segment.
It don't have line section.
Correct. So it's only a simple closed curve. This one is only a simple because it doesn't cross over itself. Closed because the starting point and the ending point is the same, and it is a curve because you can draw it without lifting your hand. The fourth one, polygon. The fourth one is the polygon because it is a simple closed curve made up of line segments. So it's a polygon. Yeah, Srijit, the fifth one. Srijit, the fifth one, is it a curve?
Yes, ma'am, it's a curve, ma'am.
Oh, you can
It's
draw
a
it.
close.
No, are you able to draw it without lifting your hand?
Yes, ma'am.
Yeah. So it's like this. No, see here, like this. Those who
Yes, ma'am.
don't understand how to draw, see here. You should go like this. See here. Did you notice that?
Yes, ma'am. Yes, ma'am, I can see that.
Yeah. See here.
Ma'am, it's
See
a
here.
closed
See,
curve.
one second. No, I'm just trying to draw that. So like this, like this. Yeah.
Yes,
so you can draw it without lifting your hand. So it is a curve. Sridhar,
ma'am.
is it a closed curve?
Yes, ma'am, it's a closed curve, ma'am. Because
Why?
it's crossed itself, ma'am.
No. What's the definition for a closed curve? The starting point and the ending point should be the same.
Yes, ma'am.
Yeah, is the starting point equal to the ending point? Yes, because see,
Yes,
you start
ma'am,
here.
yes,
No, you start here. And see, you go like this,
yes,
you
ma'am.
go like this, you go like this, and you come back to the starting point.
Yes,
So
ma'am.
it is a closed curve.
Closed curve, ma'am.
Is it simple?
No, ma'am, it's not simple, ma'am.
Because it's crossing over itself. So it's only
Yes,
a closed curve. Yeah, it's only a closed curve.
Yes, ma'am.
Yeah. Again, Harini, this one. You should give the name of the highest order. See, if you look at an animal on the road, you will not say that an animal is going there. You will say it's a cat or a dog or a hen or a goat or a cow, whatever it is, right? If when you say animal, you're right. I can see a bird flying in the sky, but if you can name it as a crow or a sparrow or a pigeon, so like that, give a specific one. Polygon, very good, Harini. Polygon. Because it is a curve, it is a closed curve, it is a simple closed curve, it is made up of line segments. So it's a polygon. It's a curve because you can draw it without lifting your hand. It's a closed curve because the starting point is equal to the ending point. It is simple because it's not crossing over itself. So it is a simple closed curve and it is made up of line segments everywhere. So it is a polygon. Very good. Yeah, next who's it is? Anirudh? Open curve. Very good. Open curve because the starting point is not equal to the ending point. Then next one, Navneet. Polygon. Okay. Is it a simple closed curve, Navneet? Is it simple? Why? It's crossing over itself. It intersects itself. So it's not a polygon. Is it a simple closed curve? No, but it's a closed curve. Yeah, because you can draw it without lifting your hand. Here like this. Correct? Correct? So this one is a closed curve. It's a closed curve, but it's not simple because it's crossing over itself. If it is not simple, then it cannot be a polygon. Polygon, it has to be simple. If it's a polygon, it should be simple. So this one is a closed curve. Curve because you can draw without lifting your hand, and it's closed because the starting point is equal to the ending point. Because you can draw it like this. See here, I start here like this, I go like this. I come back to the starting point. Yeah, next. Next, polygon. Polygon. This one is a polygon. Oh, I think it was Srijit's turn. Okay, sorry. Okay, Srijit, this is a polygon. Have you got it right?
Yes, ma'am. It's a polygon, ma'am.
Yeah, because it is simple.
Yes,
It's a
ma'am.
closed curve made up of line segment. Next one, Srijit. Can you draw this figure without lifting your hand, Srijit? This one?
No, ma'am.
You cannot draw without lifting your hand because you'll have to make one oval, lift your hand and only then make the next one.
Yes, ma'am.
So it is not a curve at all.
Oh, yes, ma'am.
I have not given. I'll change the heading. In my heading, I have only these options: open curve, closed curve, simple, and polygon. Okay, but the answer for this one is not a curve. It's not a curve.
Not a curve. Okay, ma'am.
Because you cannot draw this without lifting your hand. You have to lift your hand to draw that. So it's not a curve.
Yes, ma'am. Okay, ma'am.
Then next one, Srijit.
Next one is a polygon, ma'am.
Polygon. Very good.
Because it has line segments.
Correct. Harini, next one. Closed curve. Simple closed curve. Because it doesn't intersect itself anywhere. It's closed and it's simple closed curve. Next one, Anirudh. It's not a polygon?
Oh, yeah, it's polygon. Huh? No, it's simple.
Is it a polygon, Navneet?
No, ma'am.
Why?
Because it's not made of line segments.
It's not completely made up of line segments. Not completely made up. It is. You can see line segments, but it's not completely made of line segments. It's a simple closed curve. It is a simple. It's simple because it doesn't intersect itself. Simple closed curve. You can draw it without lifting your hand, right? Like this. Then you can come like this. எந்த ஆர்டர்ல வேணாலும் நீங்க ஆரம்பிக்கலாம். But you are able to draw it. You can start from anywhere. Yeah, next one. Now tell me. Just look at that and tell me. Simple closed curve. Simple closed curve. This one is simple closed curve, correct? Yeah. Last one, Srijit. See, you can draw it by lifting your hand. The thing is it possible to draw without lifting is the question. It is possible. You can draw it without lifting. See here. I do it without lifting. So it is a curve. But the starting point and the ending point, they're different. So it's not a closed curve. It's an open curve. It looks like closed for you. It's an open curve. See here, it is a curve. Use the definitions. Use the definitions. Is it a curve? Yes, because see, we are able to draw it without lifting. See here, we are able to draw it without lifting. See, without lifting, we drew it. So it's a curve. But we started here, went like this. This is the ending point. If you started here, this is the ending point. The start point is not equal to the end point. So it's an open curve. It is an open curve. It is a curve because you can draw without lifting. And it's an open curve because the starting point and the ending point, they're different. Yeah, please fill it up. It's okay, you can finish it later. Shrijit, did you complete the pre-work which I had shared on WhatsApp? No? Can you hear me, Shrijit?
Ma'am?
Did you complete the pre-work which I had shared with you on WhatsApp?
Ma'am, I didn't saw that, ma'am.
Okay, fine. All right.
My
I'll
mother
shortly-
didn't share it to me, ma'am. So,
All right, we'll discuss that later. We'll see what can be done. Okay.
okay, ma'am.
Next one. Yeah. Now, in the heading, நான் share பண்ணப்ப அந்த heading இருக்குல்ல. நீங்க வரணும், you have these two columns. All right. So the heading is match the columns. Now do this. Match the columns. Use a pencil. Match the columns in your book. Srijit, see, the others have completed the pre-work. So it's easy for them. They're just matching it now. You can just, like keep the answer ready. So when we discuss, you can share your answers.
Okay, ma'am.
That's why the pre-work is given, because imagine in the class, if you have to draw all this and then answer the question, it's time consuming. So whenever there is some writing thing to be run, I normally share that as pre-work so that you can do that at home and we can cover more in the class. We don't have to spend time writing things. Okay.
Yes, ma'am.
Writing the questions, I mean.
Okay, ma'am.
Yeah. Match the columns, keep your answers ready. Disable your mic. Yeah, done? Okay. Ready? Okay, I'm going to match it and tell me how many you get. 4 on 4. 4 on 4 or 0 on 4. That's all. Either it is 4 on 4 because ellame correct. Only then it means you have understood clearly. Yeah. No 1 out of 4, 2 out of 4, 3 out of 4. 3 on 4 you cannot get. Okay. So it's either 0 on 4 or 4 on 4. Okay. All right. Ready? Okay. Let me see first. I should match it correctly. So what I do is I'll just read this and match it like this first. So simple closed curve. Which of this is a simple closed curve? This one is not simple because it's crossing over itself. This also is not simple and it's also open. So from these two sources, this one only. See, I'll read this. I'll not see the figure and try to find the name. I'll read the name. Simple closed curve. Okay, simple closed curve. This open, this varadu, this open, this open so varadu. This simple illa varadu. அப்ப இதான் இப்ப இதுக்கு செக் பண்ணுங்க கரெக்டா வருதான்னு. Yeah, this one is simple because it doesn't cross over itself and it's a closed curve. It's a curve and it's closed also. You ask me after I tell you the answers. Okay, so I do like this. Then a closed curve that is not simple. That means it should cross over itself, but it should be closed. See that a closed curve. It should be a closed curve. That is not simple.
Both one, ma'am.
Okay, it should not be simple. Simple, na, it should cross over itself, but it should be closed. So it has to be, see, it should not be simple. No, this one is not simple. This one also is not simple. See, this one is not simple. This one is also not simple. But this one is open. This one only is closed. So right, Srijit. So this one, you go with this one. See, you first see the options. See, for the second one, you first see the options that are not simple. Which of these are not simple? This one is not simple because it's crossing over itself. This one is also not simple. See, you don't know when I'm explaining, look at the board. All right. Not simple. Which were the two figures? Not simple. This one not simple. This one not simple because crossing over itself. These two are not simple. But which of these two is closed? The fourth one is closed. The second one is open. So the fourth is the correct one for B. Then C. Simple curve that is not closed. It should be simple but not closed. It should be simple but not closed. That means what? It should be open. Simple, Anna, simple it should not cross over itself, but it should not be closed. That means it should be open. So this one, no. Yes or no? The first one is a simple curve. Why is it a simple curve? Because it's not crossing over itself. Is it a curve? The first one, yeah, it is a curve. Is it simple? Yeah, it's not crossing over itself. It's not closed. Yeah, it is open. Then, not a simple curve. Not a simple curve. Which is left now? This one. This is not a simple curve. How did you get 4 on 4? Srijit, what's your score?
Ma'am, 4 and 4, ma'am.
Very good. Dhanvan also here. Very good. Shall we do it again? You understood? Okay. Okay. See, I'll do it again. first option, simple closed curve. It should be closed and it should be simple. Okay. See, this one is not simple because it's intersecting. This one also is not simple because it's intersecting. So these two will not come for the first one. Okay. It should be simple and closed. So these are the only two options remaining. These are the only two options remaining for the first one. So which is the correct option? Simple closed curve. This one, right? Then the next one. So this is gone. Now we have only three figures. Now a closed curve. Now which of the remaining is closed? Only this is closed. Which of the remaining is closed? A closed curve. So this is open. This is also open. This only is closed. So this is the closed curve which is not simple. So, finished. Next. Simple curve, it should be, now these two options are gone. We have only these two remaining. Simple curve, it should be simple. That means it should not cross over itself. So which one then? Yeah, simple curve, and it's not closed, it's open. And this one, it's not a simple curve, yeah, because it's crossing itself. Figure line, that match is mostly easier always. Instead of looking at one figure and checking which option it will go with, it's better you take the, the verbal thing and match that with the figure. That's mostly easier. Or whichever is easy for you. Okay. So classification of polygons, a polygon with three sides is called a triangle. A polygon with three sides is called a triangle. A polygon with four sides, quadrilateral. A polygon with five sides, pentagon. 6 sides, hexagon. 7 sides, heptagon. 8 sides, octagon. 9 sides, nonagon. 10 sides, decagon. In general, a polygon with n sides, suppose 15 sides, is called 15 gun. N gun. A polygon with n sides. So supposing 50 sides, 50 gun, meaning a polygon with 50 sides. Huh? Oh, okay. Yeah. No, see, it's not nano gun, it's nana. Nano means a small. Nano, you have this car version, no? Nano. Nano means a small. Nano means very little, very small. It's not nano gun, it's nana gun. Nana. Nana gun. Nana gun. This is correct. It is not nano gun. It is not this. This is wrong. Nano is wrong. It's nana gun. What you see here is right. Nana gun. No, goes down like I'm saying it continues like. Yeah. It goes on like that, I meant. And it goes on like that. No, that's what is the meaning. So it goes on like that. N sides is, if the number of sides is n, then the polygon is called n gun. So 25 sides, 25 gun. Right? There are some special names for 12, 15 and all that, but you don't have to, you just have to remember till 10. That is, in our books, you will have names only for polygons up to 10 sides. No, don't draw. I didn't send that. Okay, now what's a diagonal? What is a diagonal? Now, look at this. These are the vertices, right? These are the vertices. Now, the line segment joining any two consecutive vertices. Consecutive meaning? one after the other. Yeah. So the line segment joining two consecutive vertices is called the side of the polygon. The line segment joining two non-consecutive vertices is the diagonal. Now see here, 1, 2, 3, 4. I have numbered the vertices. Okay, 1, 2, 3, 4. Now 1 and 2 are consecutive vertices. 1 and 2 are consecutive vertices. If you join vertex 1 and vertex 2, that's a side. That line segment is called the side. Now 2 and 3, vertex 2 and vertex 3 are consecutive, meaning comes one after the other. So if you join vertex 2 and vertex 3, it's a side. If you join vertex 3 and 4, vertex 2 and 3 is a side of the polygon. If you join 3 and 4, it's a side. 4 and 1 is a side. So the line segment joining any two consecutive vertices of a polygon is a side. If you join any two non-consecutive vertices, it's the diagonal. So we'll, instead of joining 1 and 2, we'll join 1 and 4. We'll join 1 and 4. 1 and 2 are consecutive, no? So, sorry, not 1 and 4, 1 and 3. 1 and 2 are consecutive, right? So let's join 1 and 3. That's a diagonal. Join 2 and 4, diagonal. Because which are consecutive? With 2 and 1 are consecutive, or 2 and 3 are consecutive. 2 and 4, they are not consecutive. After 2 is not 4. After 2, we have 3 and then 4. Or after 2, like with 2, we have 1 and then 4. So if you join 2 and 4, they are non-consecutive vertices. So if you join, you get the diagonal. All right. Similarly here, let me mark this vertex 1, vertex 2, vertex 3, vertex 4, vertex 5. Okay. So vertex 1 and 3, are they consecutive? 1 and 3? No. There is 2 between them. So if you join 1 and 3, diagonal. If you join 3 and 4, they are consecutive. So it's a side. Altitudes will form from the vertex and it will go perpendicular to the opposite side. Altitude is not joining two vertices. Yeah, joining. No, altitude is not from one vertex to another vertex. Altitude is from one a line segment from the vertex perpendicular to the opposite side. So like, see, from this vertex perpendicular to the opposite side is altitude. Straight, yeah. Should make 90 degrees with the opposite side. Okay. So 1 and 3, they're not consecutive. So if you join vertex 1 and vertex 3, diagonal. If you join vertex 2 and vertex 5, diagonal. If you join vertex 1 and vertex 4, diagonal. 3 and 5, diagonal. 2 and 4, diagonal. So like that. Okay, you got that? So a diagonal is a line segment connecting or joining two non-consecutive or non-adjacent vertices of a polygon. A diagonal is a line segment. Okay, line segment because it has fixed endpoints. And it joins what? Two non-consecutive or non-adjacent vertices of a polygon. Okay. Now, how do you find the number of diagonals in a polygon? It's given by this formula, n into n minus 3 by 2. So supposing a polygon has 20 sides, you cannot connect and find how many diagonals it has. It's time consuming, right? You cannot draw, you should first draw the polygon with 20 sides. And then you should connect the non-consecutive vertices to find the number of diagonals. So that's going to be time consuming. So we have this formula that will give us the number of diagonals a polygon can have. So if the polygon has 20 sides, it will have 20 into 20 minus 3 by 2. So many diagonals it will have. So simplify, 2 ones are, 2 tens are. So now 10 into 17, 170 diagonals. A polygon with 20 sides can have 170 diagonals by joining non-consecutive vertices. Correct. So n into n minus 3 by 2 is the formula that will help us find the number of diagonals in a polygon. Okay, where n stands for the number of sides that the polygon has. N stands for the number of sides the polygon has. So if the polygon has 100 sides, it will have 100 into 100 minus 3 by 2. 2 ones are 250 times. So it is 50 into, what is 100 minus 3? 97. So 50 into 97. What is 50 into 97? 4,850 diagonals. Got that, Srijit? Now, a triangle does not have diagonals. A triangle does not have diagonals. So how many sides the triangle has? 3. 3 into 3 minus 3 by 2. So that is 3 into, what is 3 minus 3? 0. 0 by 2. 3 into 0, 0. 0 by 2 is 0. So a triangle has no diagonals. A triangle has no diagonals. Now a quadrilateral has 2 diagonals. A quadrilateral has 2 diagonals. Quadrilateral means 4 sides. So 4 into 4 minus 3 by 2. In the 3 should come down. Quadrilateral. N is 4. 4 into 4 minus 3 by 2. 2 ones are, 2 twos are. So it is 2 into 4 minus 3 is 1.
2, ma'am.
2 diagonals. All right. Okay. Now that's what you see here. PQRS. Srijit, give a special name for the quadrilateral PQRS.
Ma'am, quadrilateral or rectangle, ma'am?
Rectangle. It's a rectangle. Rectangle.
Okay, ma'am.
You can see. Yeah, it has 2 diagonals. Okay. Then what do you call this figure? A, B, C, D, E. What's the special name for this polygon? A, B, C, D, E.
Pentagon, ma'am.
Pentagon. This one is a pentagon. This one is a pentagon. All right.
Pentagon,
And you
ma'am.
can. Sorry.
Yes, ma'am.
Okay, this one is ABCD is a pentagon, and you can see
Yes,
the diagonals connected. Okay. This one, KLMN. From the number of vertices, you can name the figure. How many vertices are there? KLMN. 4 vertices. Quadrilateral. 3 vertices. Triangle. 4 vertices. Quadrilateral. I'll tell you what it is. One second, please. Let me see. The quadrilateral is like this.
Yes, ma'am. It's a quad. Yes,
This is
ma'am.
the quadrilateral. K, L, M, N. This is the quadrilateral. See, from the number of vertices, you can make out. You can make out what polygon it is. So this one has 4 vertices, right? K, L, M, and N. 4 vertices, meaning quadrilateral. Now these are the diagonals. When you join K and when you join the vertex K to the vertex M, it's a diagonal. When you join the vertex L to vertex N, it's a diagonal. The diagonals you can see there. Dotted lines are the diagonals. In all the 3 figures, the dotted lines are the diagonals. This is the quadrilateral, like an arrowhead. That's the quadrilateral. K, L, M, N is the quadrilateral. And how do you show the diagonals? Joining the opposite vertices K and M. This is one diagonal. Joining the opposite vertices L and N. See, I'll tell you. See, 1 minute. What's the name of this quadrilateral? K, L, M, N. Correct? You should go in the order. K, L, M, N. Okay. So when you connect this and this, K and M, that's one diagonal. Focus is 0. Okay, when you join L and N, L and N. See, can you see? Correct order. The name of the quadrilateral is KLMN. If you join vertex K and vertex M, can you see in the figure? Can you see the dotted lines? Vertex K and vertex M, they're connected. That's a diagonal. Join vertex L and vertex N. That's the other diagonal. Got it? Yeah, 1 and 3, 2 and 4. But you should name the quadrilateral in the correct order. See, like you should mark this P, Q, R, S. P, R, S, Q. Like this, you should not write. Yeah. It should be in the clockwise or the anti-clockwise direction. Correct. Correct. So if you see here, K, L, M, N. Okay. Right? So that's about the diagonal. And this is the formula. Remember this, the formula to find the number of diagonals in a polygon. Okay. Next, convex and concave polygons. Convex and concave polygons. All right. Now, with respect to triangles, we have seen, no? What is an acute triangle? An acute triangle is a triangle in which all the three angles are acute. An obtuse triangle is a triangle in which one angle is obtuse. Only one angle will be obtuse. An obtuse triangle is a triangle in which one angle is obtuse. An acute triangle is a triangle in which all the three angles are acute. Similarly, concave and convex polygons. In a convex polygon, each interior angle will be less than 180 degrees. Each interior angle, meaning all the interior angles will be less than 180 degrees in a convex polygon. In a concave polygon, at least one angle will be more than 180 degrees. Not all more than 180. Like all the angles are not obtuse in an obtuse triangle. In an obtuse triangle, a triangle has three angles, right? A triangle has three angles. Now, what is an obtuse triangle? A triangle in which one angle is obtuse, not all three angles obtuse. Then the sum of the angles will go more than 180 degrees. Then it's not a triangle. Because the sum of the three angles of a triangle is equal to 180 degrees. Okay, so see, similar, I'm just trying to relate something. How do you define an acute triangle? See, let me just show you something. Now, this is 30 and say this is 60. Now, this angle is acute. This is acute. Is this an acute triangle? No, it's a right triangle. Because this one is 90 degrees. Just because 30 degrees is acute and 60 degrees is acute, it is not an acute triangle, because in an acute triangle, all the three angles must be acute. So this one is not an acute triangle. It's a right triangle, because in a right triangle, one angle is a right angle. Similarly, in an obtuse triangle, one angle is more than 90 degrees. In an obtuse triangle, one angle is more than 90 degrees. Okay. If all three angles are less than 90, acute. If one angle is equal to 90, right. If one angle is more than 90, obtuse. In the same way, convex means all the angles are less than 180 degrees. Concave means at least one angle is more than 180 degrees. So you can see here in all these figures, all these angles will be less than 180. Less than 180. All these angles will be less than 180 degrees. All these angles less than 180 degrees. All these angles will be less than 180. Do we understand? But here in this figure, see, these are the interior angles. 1, 2, 3, 4. This angle is a reflex angle. This will be more than 180 degrees. Because, see, can you see, this is kind of 90 degrees, no? Can you see this kind of 90, right? Or just giving a rough value. Rough value, can you just believe that this 90? So how much is this one? 360 minus 90, 270 degrees, more than 180. So this one is a concave polygon. This one also, see, you should check the interior angles. This one is interior. I'll just simply, these are the interior angles. See, I've marked all the interior angles. Okay, so how many? 1, 2, 3, 4, 5, 6, 7. So give us what's the name of this polygon? It's a heptagon. It's a heptagon. How many line segments are there? Because 7 angles, 7 line segments you can see there. I'll come from the beginning. See here. I'm marking off all the interior angles. 1, 2, 3, 4, 5, 6, 7 interior angles are there. That means there are 7 line segments. Check them. See here. 1, 2, 3, 4, 5, 6, 7. There are 7 line segments. Simply don't look like this and say it's a pentagon. It's not a pentagon. There are 7 sides. It's a heptagon. So that's why there are 7 angles, 7 interior angles. Now you don't say, why you're not marking this angle? That's an exterior angle. Mark all the interior angles. This angle is an exterior angle. This one is an exterior angle. We are marking only the interior angles. This is inside the figure. This is inside the figure. This is inside the figure, inside the figure, inside the figure, inside the figure, inside the figure. And in this figure, this interior angle is more than 180. You'll be like, how do you know? Did you measure? I don't know, but I can guess because this angle will be kind of 40 degrees or 50 degrees. It can't be 90, no? That's not 90. Something like 50 degrees, say. So this angle will be 360 minus 50. 360 minus 50, 310 degrees. It's more than 180 degrees. Concave polygon. Similarly, in these figures, these angles are more than 180 degrees. It's a concave polygon. So how do you make out without, actually checking on the angles? How can you make out? Can you see an opening kind of like a cave? No? Can you see a mouth? Can you see a mouth opening? Just imagine it's some animal and with its mouth open. Cave. Cave, the mouth of the cave. Yeah, cave. Can you see cave? Concave. Cave means, don't you say mouth of the cave? Mouth of the cave. That is where you enter the cave. That's called the mouth of the cave. So here you can see that kind of a mouth, no? As if an animal has kept its mouth open. See here also, something open. Can you see like, just an imagination. See here, it's open. See here, it's open like this. It's open. Concave. So if you look at the figure, you can say, just by looking, you can say it's concave. All these figures have a mouth like opening here. See here, like this. Here. So these figures are concave polygons. Concave polygons. And in a concave polygon, at least one interior angle will be more than 180 degrees. Not all. At least one will be more than 180 degrees. Now, Navneet, give a special name to this polygon. All of you have the answer ready? Srijit, have the answer ready? I'll ask you. Give a special name to this polygon.
Hexagon, ma'am.
Hexagon, correct. It's a hexagon. It's a concave hexagon. It's not a convex hexagon. It's a concave hexagon. All right.
Okay.
This one, is it here? This one. This one is 1, 2, 3, 4, 5, 6. This one is a convex.
Convex. Hexagon.
This figure, this one has 6 sides, 6 line segments. This one also 6 line segments. So both are hexagons. But this one is a convex hexagon. There's a concave hexagon. All right. Now give a special name to this figure. Anybody can say it? Quadrilateral. Give a special name to this figure. 1, 2, 3, 4. Quadrilateral. Quadrilateral. One, 2, 3, 4. 1, 2, 3, 4. Here this is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So what's the special name for this polygon? Convex quadrilateral. And this one? Concave quadrilateral. Concave quadrilateral. Correct? Yeah. Count the sides. 1, 2, 3, 4, 5, 6, 7, 8. Convex octagon. Convex octagon. I'll draw for you. Check how many sides. This one we already counted, no? We already counted, no? 1, 2, 3, 4, 5, 6, 7. Huh? Yeah. The number of, in any polygon, the number of sides and the number of interior angles will be the same. Yeah, 3 sides, 3 angles. 4 sides, 4 interior angles. So you can count the angles or the sides. So this one is a concave heptagon. Heptagon. This one? Concave. This is concave. Huh? Oh, you're talking about this one. Okay, 1 second. You're talking about this one. 1, 2, 3, 4, 5. What is this? Concave pentagon. Concave pentagon. Very good. Concave pentagon. What about these two? Convex. It's a convex polygon and it's a convex quadrilateral. Very good. These two are convex quadrilaterals. So concave, you should be able to make out when you look at the figure. When you look at the polygon, you should be able to say if it is concave or convex. Cave meaning it will have a mouth like opening. This is concave. And then count the sides and give the special name for the polygon. So what, by the definition, what is a concave and convex polygon? In a concave polygon, at least one interior angle will be more than 180 degrees. What do you call an angle? Srijit, what do you call an angle which is more than 180 degrees?
Concave polygon, ma'am.
No. What do you call an angle? See, if an angle is equal to 90 degrees, we call it a right angle. In the same way, an angle whose measure is more than 180 degrees, but less than 360 is called a... If the measure of an angle is more than 180 degrees, but less than 360 degrees, then the angle is called?
Concave angle.
No, we're talking about angles. Okay, Srijit, if an angle measures less than 90 degrees, what do you call that angle?
Acute angle.
Acute angle. An angle whose measure is exactly 90 degrees?
Right angle.
Exactly 180 degrees? Straight angle.
Straight angle.
Good. Straight. This is only one angle. Supplementary angles means 2 angles whose sum is 180.
Yes, ma'am.
Okay, an angle whose measure is equal to one angle. One angle.
Straight angle.
Straight angle.
Yes, ma'am.
An angle whose measure is equal to 360 degrees.
Full angle.
Complete angle. Complete angle. Now, My question was, name the angle. What is the name given to an angle whose measure is more than 180 but less than 360? Reflex angle.
Reflex angle.
Reflex angle.
Reflex
Reflex angle is
angle.
an angle whose measure is more than 180 but less than 360 degrees.
Okay, ma'am.
Reflex angle. So children, see here. So in a concave polygon, at least one angle is a reflex angle. Because more than 180 we said, no? So in a concave polygon, at least one angle is a reflex angle. No, interior angle is a reflex angle. Yeah, opening, the inside of the opening. Yeah, correct. That will be a reflex angle. Okay. So see here, a polygon in which each angle is less than 180 is a convex polygon. At least one angle is more than 180 is a concave polygon. Now tell me, I related this one to triangles, no? What did I say? Correct. What did I say? Acute triangle. In an acute triangle, all three angles are acute. But in an obtuse triangle, one angle is an obtuse angle. Similarly, in a right triangle, one angle is a right angle. அது மாதிரி தான் இந்த definitions இங்க. Convexக்கு எல்லா angles-உமே less than 180. But concave-னா at least one angle should be more than 180. எல்லா angles-உம் இல்ல. Yeah. Regular and irregular polygons.
Regular polygon.
Okay, so regular and irregular polygon. So now when we talk about polygons, it is made up of lines. It's made up of line segments. It's a closed figure made up of line segments. So you can find line segments and interior angles, right? So, so to understand the term regular and irregular, it's about the sides and angles. It's about the sides and angles of the polygon. In a polygon, if all the sides are equal and all the angles are also equal, it's a regular polygon. Now let's take a square. In a square, let's say a square of side 4 centimeters. In a square, all the sides are equal and every angle is equal to 90 degrees. So all sides are equal and all angles are equal. It's a regular polygon. A square is a regular polygon. An equilateral triangle. An equilateral triangle. All the three sides are equal. Each angle is equal to 60 degrees. An equilateral triangle is a regular polygon because all the three sides are equal and all the three angles are also equal. See, side or a value will not be equal to the value of the angle. See, if the angle is 60 degrees, side will not be 60 centimeter. The three sides should be equal. That is over. They can be all 3 centimeters or all 4 centimeters, 5 centimeters, whatever. And the three angles are equal, each one equal to 60 degrees. Disable your mic, Srijit, please. You can unmute when you have to talk something. So an equilateral triangle is a regular polygon because all the three sides are equal and all the three angles are equal. A square is a regular polygon because all the sides are equal and all the angles are equal to 90 degrees. A rectangle is not a regular polygon. A rectangle is not regular because all sides are not equal. Only opposite sides are equal. All the sides should be equal. So a rectangle is not a regular polygon. We finished that. Irregular polygon, if it is not regular, it's irregular. That's all. Right? For regular, we have the definition. What is irregular? If all sides are equal and all angles are equal, it's regular. If a polygon is not regular, it is irregular. That's all. So a rectangle is irregular because all the sides are not equal. Yeah, go through. You don't understand yourself. Please go through the slide and understand for yourself. Yeah. Yeah, it's 8:40. So what do we understand when the figure you have these markings? What do these markings indicate in the figure? All the three sides are equal. And what about this? You can see here. All the three angles are equal. Correct. Each 60 degrees. Here also, can you see? What do you understand by these markings? All the sides are equal. And here, each angle is equal to 90 degrees. So it's regular. Now this one is a regular this one is an equilateral triangle. This one is a square. Now this one is a regular pentagon. Regular pentagon. Regular quadrilateral, not regular square. Regular quadrilateral. Give an example. Which quadrilateral is called a regular quadrilateral? Square. Not regular square. Okay, so this one is a regular pentagon. This one is a regular hexagon. This one is a regular hexagon. Okay, because here regular because all the sides are equal. It's marked. How do we know they're equal? It's marked. Equal. And you can see here, it's marked. All angles are equal. Same thing here. All right. So all these figures are regular. But here it's a right triangle. This is 90. So all the angles should be 90. Then only it can be regular. But that's not possible in a triangle. So this is irregular. Because it is not regular. Why is it irregular? Because it's not regular. Here also, all angles are equal. Okay, angles are equal, but all the sides are not equal, only opposite sides. So irregular. Here also. Only these two sides are marked equal. See, only these two sides are marked equal. All the sides are not marked equal, irregular. Here also, these two are, see, they've used double lines here. That means these two are equal. These two sides are equal. And for the remaining four sides, they've used a single line like this. Okay, so from this figure, see the marking? Single dashes here. All these four sides are equal. And for this one and this one, they've used double lines like this. That means these two sides are equal. Yeah, these two sides are equal. But all the sides are not equal, no? So it's not regular. See, I'm trying to make you understand what these symbols stand for. Double lines, no? So these two sides are equal. And single lines here. That means these four sides are equal, right? And what about the angles? It's marked that this angle, this angle, this angle, and this angle are equal. Two curves are, yeah. And see here for this angle, double curve, and for this also double curve. So these two angles are equal. However, all angles are not equal and all sides are not equal. So it's irregular. Yeah. Now, these formulae are very important. All right. Now listen very carefully. Listen very carefully. Certain things you need to understand it correctly, clearly the first time. If you get confused, then it's difficult to unlearn and then learn the correct thing. So listen to me carefully. How many sides? 5 sides. Now we are going to divide this pentagon into triangles by connecting some of its diagonals. Now we're going to use the diagonals of the pentagon. We're not going to show all the diagonals. We're just going to use some of the diagonals of the pentagon and divide this pentagon into triangles. That's all. We are not showing all the diagonals. We are just going to use some of the diagonals and divide this pentagon into triangles. We'll do that, okay? So see here, from here, this is a diagonal. I've got a triangle here. Then from the same vertex, have I divided this pentagon into 3 triangles? Yeah, but I have not connected all the diagonals. I have not connected all the diagonals because how many diagonals will it have? N into n minus 3 by 2. 5 into 5 minus 3 by 2. 5 into 2 by 2. 5 diagonals it has. Number 2 diagonals தான் காமிச்சிருக்கோம். நம்ம இங்க diagonals காமிக்கல. We are just dividing the figure into triangles. So we are able to divide the pentagon into 3 triangles. Now, what is the sum of these 3 angles? 180 degrees. Now, see here. We are not using the same angle again, okay? See here. Now, what's the sum of these 3 angles? What's the sum of these 3 angles? Okay. Now, have we included all these angles? Yes, only once. Yes. Have we included all these angles? Once. So like this, okay, let me do it again. Yeah, I can see that. Yes. No, I'll number it. 1 second, children. 1 second. I'll number it. It'll be easier for me to explain also. Okay. Now, what is angle 1 plus angle 2 plus angle 3, children? 180, because the sum of the 3 angles of a triangle is equal to 180. Now, what is angle 4 plus angle 5 plus angle 6? 180. Agree? What is angle 7 plus angle 8 plus angle 9? 180. 180. Okay. Now we'll add everything. Now, this is angle 1, this is angle 9. But for that, to get the other angles, we'll have to add. So I'll write angle 1, this one. Then I'll add 2, 4, and 9 to get this complete angle of the pentagon. 2, 4, and 9. So 2, 4, and 9. Okay, so plus angle 2 plus angle 4. Oh, 7, sorry, 7. 7. 2, 4, and 7. Okay, if I mark this A, B, C, D, E. Okay, angle A is angle 1, correct? Angle A is angle 1. Now I want to get angle B. What is angle B made up of? 2, 4, and 7. So I've grouped them. Then what is angle C? Angle 9. Then what is angle D? Angle 8 plus angle 6. And what is angle E? See, we are adding these 3 equations. Do we understand these 3 equations? How did we write these 3 equations? No, 1 minute. How did we write all these 3 equations? We understand? Angle sum property. Then we add the 3 equations. So see, we've written angle 1 here, 1. So we've used this one. Then 2, 4, 7. 2, 4, 7 is here. Then 9. 8 and 6. 8 and 6. And then 3 and 5. 3 and 5. So we have added, but in a specific way we wanted, but we've used all the angles. We have shown all the angles. Okay, is equal to 180 plus 180 plus 180 is 540. 540. Now what is angle 1? Angle A. Plus what is 2 plus 4 plus 7? Angle B. Plus angle 9 is angle C. Angle 8 plus angle 6. Don't say angle 8 plus angle 6 is angle 14. Angle D, not angle 14. Okay, plus. What is angle 3 plus 5? Is equal to 540. Now, what do you understand by angle A plus angle B plus angle C plus angle D plus angle E? The sum of the 5 interior angles of the pentagon. The sum of the 5 interior angles of the pentagon is 540 degrees. What is the sum of the 3 angles of a triangle equal to? 180 degrees. In a quadrilateral, the sum of the 4 angles is equal to 360 degrees. Yeah, so the... Sorry? 1 minute. In which one? Pentagon. Yeah, each angle. Yeah, if it's a regular pentagon, not otherwise. Yeah, if it is not regular, each angle will not be 108. Yeah, correct. Do you understand what's happening? I considered a pentagon ABCDE. I divided the pentagon into 3 triangles. 3 triangles. And we, using the angle sum property, we wrote 3 equations. Using the angle sum property, we wrote 3 equations. Then we add all the 3 equations. We add all the 3 equations. We group the angles in a desired way so that we get these angles B and D and E. Correct? So when you add, you get all the 5 angles equal to the sum of all the 5 angles equal to 540 degrees. 180 plus 180 plus 180 is 540. But do you think you can do this for every other polygon? No, you need to have a formula, right? You need to have a formula to find the sum of all the interior angles of any polygon. For a triangle, we know is 180. For a quadrilateral, 360. Now we found for a pentagon is 540. The sum of the 5 angles of the pentagon is 540. So the formula is like this. How many sides does the pentagon have? 5 sides. But you are able to divide it into how many triangles? 3 triangles. That is, if it has 5 sides, the number of triangles is only 3. That means n minus 2 triangles. If the figure has n sides, you can divide it into n minus 2 triangles. No, n stands for the number of sides. N stands for number of sides. How many sides does this how many sides does this figure have? This polygon have 5. How many triangles you got? 3. So 5 minus 2, no? Yes. 5 minus 2. 5 minus 2 triangles you got. Now each triangle, the sum of all the angles is 180. So n minus 2 into 180. N minus 2 into 180 will help you find the angle sum property of any polygon. See, 1 minute. We'll take one more. Now consider this one. This one is a hexagon. 6 sides, a hexagon. Now see, we'll divide it into triangles. That's all. No, it should not intersect. It should not cross over itself. How like this, huh? Yeah. That's also fine. Yes. That's also fine. Anyways, you draw, but it should not. They should not overlap. Like you cannot draw a line like this. You cannot draw like this. It should be like 4 independent triangles. When you fix them together, you get the hexagon. It should be like 4 triangular pieces. When you put them together, you get the hexagon. One second. So not this one. Okay. Correct? No, I didn't finish it. Ah, it was incomplete. No, 1 minute. Without this one is not a triangle. No, it's a quadrilateral. Without, you should divide it into triangles. Any given polygon, you should divide the polygon into triangles. If you leave it like this, it's incomplete. So you have to do, you'll have to either do this. You'll have to either do this or this. Anything. So now 1, 2, 3, 4 triangles. How many sides? 6 sides. But how many triangles? 2 less. You can divide the hexagon into triangles in different ways. This is not the only way. In different ways you can do it. Okay, we'll just do one more method because we'll just do one more method. You can do it in many ways. See here, you can choose any vertex. Choose any vertex. From there, you should join only from that vertex. See, like this one. Choose one vertex. See, I chose this vertex, okay? This vertex. 1, this is one triangle. 2, this is the other triangle. See, I'm going from this. This is the vertex from where I'm joining. 3 and 4. Like this, you can do in different ways. The thing is, you should divide the polygon into triangles. 4 triangular pieces put together should make that polygon. Is this fine? So how many triangles are you able to get here? 4 triangles. But how many sides the polygon has? 6. So you're always getting 2 triangles less. You're always getting 2 triangles less. If it has n sides, you're getting n minus 2 triangles. Now see quadrilateral. You can only do this one. You get 1 triangle here, 1 triangle here. A quadrilateral has 4 sides, but you're getting only 2 triangles. So number of triangles you get is 2 less than the number of sides. That's why n minus 2. Now why into 180? Because n minus 2 is the number of triangles. For each triangle, the angle sum property is 180. So n minus 2 triangles will be n minus 2 into 180. What is the sum of all the angles in each of the triangles? If there's one triangle, the sum of the angles is 180. 2 triangles, 2 into 180. 3 triangles, 3 into 180. N minus 2 triangles, n minus 2 into 180. Simple. If the polygon has n sides, you are able to divide the polygon into how many triangles? N minus 2 triangles. How many ever? If it has 10 sides, you can make 8 triangles. If it has 10 sides, you can make 8 triangles. If it has 20 sides, you can make 18 triangles. By choosing one vertex and by continuously joining like that, you can make 18 triangles. So you will always get 2 triangles less than the number of sides. If the number of sides is n, you will get n minus 2 triangles. Yeah, because it has 6 sides, you'll get 6 minus 2, 4 triangles. Okay, that's one part. Now for each triangle, what's the sum of the angles? 180. So for one triangle, 180. 2 triangles, 2 into 180. 3 triangles, 3 into 180. 4 triangles, 4 into 180. For n minus 2 triangles, n minus 2 into 180. So the formula to find the sum of all the interior angles of a polygon is n minus 2 into 180. N minus 2 into 180. Okay. If a polygon has n sides, you can divide it into n minus 2 triangles. One triangle, the sum of the angles is 180. So n minus 2 triangles will be n minus 2 into 180. So you cannot forget the formula. Don't say, I forgot the formula. I went wrong in writing the formula. You cannot say. If a polygon has n sides, it can be divided into n minus 2 triangles. For one triangle, 180 degrees. For n minus 2 triangles, n minus 2 into 180 degrees. So this is the formula that will give you the sum of all the interior angles of any polygon. You discuss with your friends later. You check if they understood. Ask your friends later. All right. So this is the sum. This is the formula that will give you the sum of all the interior angles of a polygon. Now how many sides the polygon has? No, n minus 2 into 180. In this formula, how many sides the polygon has? N sides. So how many angles? How many n sides means n angles? Yeah, not triangles. If it has n sides, how many angles? N angles. So this is the sum of all the angles. If it's a regular polygon, if it is a regular polygon, each interior angle will be, each interior angle will be n minus 2 into 180 divided by n. Because if a polygon has n sides, it has n angles. N sides, n angles. Okay, if it has n minus, sorry, if a polygon has n sides, it has n angles. What's the sum of all the angles? N minus 2 into 180. This is the sum of all the angles. If all the angles are equal, each angle will be divided by n. Yeah. Why divided by n? Because there are n angles. So each angle will be divided by the number of angles it has. Correct. Correct. Only if it's a regular polygon. Because only in a regular polygon, all angles are equal. Okay. So n minus 2 into 180 is the formula that gives us the sum of all the interior angles of a polygon. If it's a regular polygon, each interior angle will be n minus 2 into 180 by n. All right. Tell me. Sum of all interior angles of a polygon. Sum of all interior angles of a polygon is equal to n minus 2 into 180 degrees. If it is a regular polygon, in a regular polygon, each interior angle will be n minus 2 into 180 divided by n. All right. Okay. Now coming to each exterior angle. Now in any polygon, the sum of the interior angles of a polygon will keep increasing as the number of sides increases. Now a triangle has 3 sides. The sum is 180. The sum of the 3 angles 180. A quadrilateral is 4 sides. The sum of the 4 angles is 360. A pentagon has 5 sides. The sum of all the 5 angles is 540. A hexagon has 6 sides. 6 sides. The sum of all the 6 angles is 720. So the sum of all the interior angles of a polygon will keep increasing as the number of sides increase. But in any polygon, the sum of all the exterior angles is always 360. The sum of all the exterior angles in any polygon, 3-sided polygon, 4-sided polygon, 5-sided polygon, the sum of all the exterior angles is always 360 degrees. Is always angle sum exterior angle sum property is always 360. So now the sum of how many? Okay, a triangle has 3 interior angles. How many exterior angles? 3 exterior angles. 3 interior angles, 3 exterior angles. What will be the sum of the 3 exterior angles? 360. A quadrilateral has 4 interior angles. What's the sum of the 4 interior angles? 360. 360. And what will be the sum of all the exterior angles? No, 1 minute. We'll just tabulate it. 1 minute. Polygon, 1 minute. Polygon, sum of all interior angles, or let me make it like this. Polygon, number of interior angles, number of exterior angles, sum of all interior angles, sum of all exterior angles. Okay. Now, polygon, triangle. Okay. Triangle. So 3 sides. How many interior angles? 3 interior angles. How many exterior angles? 3 exterior angles. What is the sum of all the interior angles? 180 degrees. What's the sum of all the exterior angles? 360. Polygon. Now the next one. 4 sides. Number of interior. 4 sides meaning quadrilateral. Let me write. Quadrilateral. How many interior angles? 4. How many exterior angles? What's the sum of all the interior angles? What's the sum of all the exterior angles? Pentagon. Sum of all the interior angles? 540. 360. Hexagon. 1 second. Hexagon. 6 sides. 6 angles. 6 sides or 6 angles? 6 interior angles, 6 exterior angles. Got it?
So for every polygon, the number sum of all exterior angles is 3, even if it's 97. Oh, even if it's 4.
For any polygon, it's not about regular, irregular. Whatever polygon, they can be regular, irregular, concave, convex. Polygon, that's all. It covers everything. Polygon covers everything. No question of is it concave, is it convex, is it regular, is it irregular? In a polygon, if it's a triangle, the sum of all the interior angles is 180, sum of all exterior angles 360. Quadrilateral, sum of all interior angles 360, exterior is always 360. Pentagon, sum of all the 5 interior angles 540, sum of all the 5 exterior angles 360. Hexagon, sum of all the 6 interior angles 720, sum of all the 6 exterior angles 360. Goes on like this. Now, if it is a regular polygon, this is what sum of all the interior angles. This is the sum of all interior angles. If it is a regular polygon, each interior angle will be by n. What's the sum of all exterior angles? 360. If it is regular, each exterior angle will be 360 by n. I'll just take a triangle and explain it for you. Now, in a triangle, I'll just mark the 70. This one, no, I'll mark this 80. 80, 60, and 40. Okay, for example. Okay. 80, 60, 40. What will be the measure of this exterior angles? 100. 100. What will be the measure of this exterior angle?
120.
What will be the measure of this exterior angle?
140.
Now add everything. Okay. See, triangle, you can see the angle sum property is satisfied. 80 plus 60, 140, 140 and 40 is 180. I've taken the three interior angles as 80, 60 and 40. And I found the corresponding exterior angle using linear pair property. Now, when you add the three exterior angles, you can see the total 360. Now, supposing this is it's obtuse, no? So I'll take 130. This also is obtuse, so let me say 140. This is acute and this is acute. The total should be how much? 360. The total should be 360. So how much is this? 100, 200, 270. How much is remaining? 270. 90 is remaining. All right, so 90. I'll take 40 here and 50 here. Or I'll take 50 here and 40 here. I'm not adjusting anything. The total should be 360. Huh? 60 and 30. I was just trying to gauge the, yeah.
I'm sorry, I take 10 and 50.
Yeah, okay, fine. No, I was like looking at the opening. I just, you want me to mark what here? 80 here, huh? And 10 here. Yes, yeah. See, like this opening cannot be 10 degrees. So I took, who's that? For you, please ask him to wait. No? Yeah, this opening cannot be 10 degrees. So I took it as 30 or whatever I marked earlier. Yeah, you can take. Okay, fine. Now the total is 360. Is the total 360? Sum of all the interior angles, 360? Yeah. Now exterior angles. How much will this be? 50. How much is this?
40. 40.
How much is this?
170.
Now add everything. 50, 40, 100, 170. 0, 9. So this will happen for all the polygons. So if the polygon has 10 interior angles, it will have 10 exterior angles. Using the interior angles, you find the measure of all the exterior angles and you add them. You will get 360. So for every polygon, concave, convex, regular, irregular, for every polygon, the sum of all the exterior angles is always 360 degrees. And if a polygon has 10 sides, it will have 10 interior angles. It will have 10 exterior angles. The sum of the 10 exterior angles will be 360. The sum of the 10 interior angles, you can calculate using this formula n minus 2 into 180. So 10 minus 2 into 180. 8 into 180. Correct? So 64, 6. 1440. This is the sum. This will be the sum of all the 10 angles, of all the 10 interior angles of a decagon. This will be the sum. 1440 degrees will be the sum of all the 10 interior angles of a decagon. Any. If it's a regular decagon, each interior angle will be 144 degrees. If it is a regular decagon, all the sides and all the angles will be equal. So each angle will be 1440 by 10. Or in other words, it will be n minus 2 into 180 degrees by n. All right. Okay. fill sum of all interior angles. What's the formula to find the sum of all the interior angles? N minus 2 into 180. Because if the polygon has n sides, it can be divided into n minus 2 triangles. So one triangle, 180 degrees. N minus 2 triangles, n minus 2 into 180. Correct? Now, if it's a regular polygon, in the case of a regular polygon, each interior angle will be, if it is a regular polygon, each interior angle will be n minus 2 into 180 by n. By n. What's the sum of all exterior angles? Sum of all exterior angles? 360 degrees. If it is a regular polygon, then each interior, sorry, I'm confused. Sum of all the exterior angles, 360. If it is a regular polygon, each exterior angle will be, if it is a regular polygon, each exterior angle will be 360 by n. How many ever sides it has? How many ever sides it has? By n. Number of sides, because number of sides is equal to the number of angles. Correct? Okay. Then also remember that each interior angle remember that each interior angle plus each exterior angle is always 180 because it angle some linear pair. Each interior angle plus each exterior angle. We worked here, no? We cleared it. That's what we found, no? In the figures earlier. Each interior angle plus each exterior angle is equal to 180 degrees because they form a linear pair. Now let's understand this slide and wind up the session for today. So sum of all exterior angles, sum of focus, sum of all exterior angles, 360. Correct? Sum of all interior angles, n minus 2 into 180. Now this 180 can be written as 2 into 90, right? You can use just this formula. In some schools, they'll use 2n minus 4 right angles, 2n minus 4 into 90. We'll do one thing. We'll just take up this because it's time. We'll just take up this in the next class. So this is what we discussed today, right? Sum of all the interior angles is equal to n minus 2 into 180, right? And then each interior angle plus each exterior angle is equal to 180. Now this is in case of a polygon. If it is a regular polygon, sum of all the exterior angles is 360. So each exterior angle will be 360 by n. Similarly, sum of all the interior angles is n minus 2 into 180. So each interior angle will be n minus 2 into 180 by n. Correct? And also each exterior angle will be 180 minus each interior angle. It's easy to understand. Each interior angle will be 180 minus each exterior angle. All right? If your school uses this formula 2n minus 4 into 90, I'll just tell you. It's just one step ahead. If you can just have some patience, I can finish it off now. Now 180 can be written as 2 into 90, right? Now multiply this 2 inside. So 2 into n, 2n. 2 into 2, 4. So you get 2n minus 4 into 90. This formula can also be yeah. 180 is 2 into 90. Multiply 2 with the terms inside the bracket. So 2 into n, 2n. 2 into 2, 4. So that's how you get 2n minus 4 into 90. 90 is nothing but right angle. So 2n minus 4 right angles. Okay. So if your teacher uses 2n minus 4 into 90, then here it will be sum of all the interior angles will be 2n minus 4 into 90, and each interior angle in the case of a regular polygon will be 2n minus 4 into 90 by n. That's all it is. 4 into 90. Correct. Yeah. All right. All right, children. So that's it for today's session. Thank you.